We're on to problem 12-27 from Fundamentals of Chapter 12, and let's get this started. So by now, we've dealt with parabolic motion and like rectilinear coordinates. So now we're doing more curvilinear components of velocity and acceleration. So now in this chapter, they introduced a new way of a new form of acceleration, right? So we have our tangential acceleration, which, it's got to be tangent to the circle, right? And that's our typical acceleration that we normally find, right? And then there's a component of the acceleration, that forms a 90-degree angle with it, and it's pointing towards the center of the circle. And this is our normal acceleration, right? This is what we feel when we take a turn in our cars, and then we feel there's some form of acceleration going into the turn. Okay. All right. So let's. So we're trying to get the magnitude of the acceleration when this boat is at t equals 10 seconds, right? So in order to get magnitude, we do what we typically do, right? And we just need to calculate this, all right? And how will we go about it? Well, first they give you velocity, right? So it's 0.0625 t squared. And I know for my tangential component of acceleration, all I need to do is just take one time derivative of velocity, right? So that's going to be dv dt, right? And that'll give me 0.125 t. Okay, so my acceleration, or my tangential acceleration at t equals 10 seconds. All right, so let's do this. At 10 seconds, right, it's going to be at 0.125 times 10, right? And then we should get 1.25 meters per second squared. All right, so this one really hasn't the way to calculate this one hasn't changed, right? All right, now in order to get the normal component of the acceleration, right, we need to get the tangential velocity of the object, right, at that instant in time. So let's say the tangential velocity squared divided by the radius of curvature. Okay, in this case we're given the radius of curvature, right? They tell us that the radius of curvature is 40 meters. Okay, so now all we need to do is find the velocity at 10 seconds, right, which we can do, right? We already know what the tangential velocity is going to be at 10 seconds, so we can just plug in the numbers. So let's calculate this velocity at 10 seconds. So v at 10 seconds. So it's 0.0625 times 10 squared. Okay, now we get 6.25 meters per second. All right, so that's the velocity. So when it's at, let's say, this point over here, this point, its velocity is 6.25 meters per second. All right, so we're going to plug that in here, 6.25 squared divided by the radius of curvature, which is 40. Okay, and then from there we get 0.977 meters per second. All right. And then finally, to get the magnitude of the acceleration at that point, we'll just square the tangential component plus square the normal component, and then pops out our answer, which is 1.586-ish meters per second squared. Okay, and that's it. So in these problems, as soon as you see a turn and they're giving you some, these are like key things to look for. Is if they give you a radius of curvature, they'll most likely want you to, find the normal component of the velocity, right? And or they'll just tell you right away. Okay. Hope this problem helped, and we'll see you in the next video. Thanks, guys.